In this video I'm going to do a brief teardown on this radio on the right, which is branded as a Retevis RT3S. Actually, as you'll see in a minute, really this radio is a TYT MD-380 UV, or sorry, UV-380, just generically known as a UV-380. This radio here is a MD-380, which I've had for several years, and this Retevis radio only came last week. So without any further ado, I will show you at least some of the differences between these radios and make some comments really on this radio. I've already taken this radio partially apart. I've already taken the knobs off the top of the radio here, and there's some rings, sort of ring nuts you need to remove. Also, in order to get this radio apart, it's the same on the GD77. To get it fully apart, you actually have to unsolder the antenna connector, which I've already done. Now, looking on the back of the radio, yeah, I think it's still in focus. Okay, so this radio is branded as a Retevis RT3S. One interesting thing is they've got a tamper, anti-tamper thing down here. So if you go to take it apart, and you want to put it back together again without Retevis noticing, you're going to have to be careful not to tear this. It is possible to peel it back a little bit, actually. I think you can do that. It's just I'm never sending this back to Retevis. I know the radio works, and even if I blow it up, that's my responsibility. So you need to peel that back. You need to remove the star washers that are there and there. Initially, I don't think you really need to take these out, but it just makes the whole thing easier to take apart if you take off the plastic section. It's the same as on this MD-380, this plastic section here, which has just got the battery retaining clip thing on it. Now, once you've done that, you can then prise this out from this end here, pull this end up a little bit, and then pull the whole thing outwards and backwards, which I'll just show you. It's already taken apart once, but it's a little bit tricky to get it out. Now, once you take it apart, you'll find you can't actually immediately just do this because of the connections between the main board and the PCB in the front of the radio. There's two connectors on it. There's the big ribbon cable here, which is the keyboard or keypad and the display. And also there's a connector to the speaker. Now, interestingly, on the MD-380 and this radio, the UV-380, they've actually put a little connector on here. On the GD77 and all the other radios I've worked on recently, these wires are directly soldered onto the PCB. But this is an older design, I suspect. In the newer design, they've saved money by not putting this connector. Yeah, it's no big deal, basically, even to unsolder that. Might make it slightly easier to disassemble for people, but really there's not a lot in it. So that's that one. In terms of taking this ribbon cable out, it's a similar design to most radios. You have to push this little black tab outwards a little bit. I don't know if I can do that here on camera, but yeah, I'll just do it with my nail. Okay, so you push this little tab outwards, and then the cable releases, and then you can take the whole thing apart and you can kind of clip that back down again. Okay, so looking on the back of this is the back, really. I think you'd probably call it the back of the PCB. As you can see, it's got UV written on it, which effectively is a giveaway in terms of what this radio really is, which is a UV or MD-UV-380, and version 2.1 and some sort of number, revision number of the PCB potentially. This is effectively the same. Looks very similar to the MD-380. I can actually show you. Yeah, I can actually show you what the MD-380 looks like, because I've got that partially apart here as well. But I will have to flip the cable connector for the keyboard apart a second. See if I can do that while still carrying on recording the video. No, I can't do that at the moment, so I'll try and just bring that in to camera shot without damaging anything. Okay, so if I push in the MD-380, which is this one here, the elastic bands to hold everything together, because if I don't do that, the battery, I can't keep the battery in, so that's all the elastic bands for. So, and these are these additional wires for me to directly program the CPU and the radio. So you can see the significant differences between the MD-380. I'll try and get them both in shot. The MD-380 and the UV-380. The CPU on both is the same, STM32F405VG. So that's the same. The flash memory, I think, is the same. I'm not compared the part numbers yet, but that's the flash memory in the UV-380, and that's it in the MD-380. This thing here, I think, is the crystal oscillator can for the 32 kilohertz real-time clock, and both of them have got a battery. The battery's there on the UV-380. And this, I don't know for sure, but generally the normal procedure is that if something's got a real-time clock and you're using the CPU for the real-time clock in a low-power sort of standby operation, then you have a watch battery like this, and this is effectively the same sort of crystal oscillator you have in a watch, in a digital watch. It's just that the CPU does that function, and it's the same on the MD-380. That's the little crystal there, or resonator, I suppose you could call it, and the battery is in a different location. I can't actually place that on here. No, maybe it's underneath some of the gubbins that I've soldered on. I thought there was oh, it's down here. Sorry, it's down, hiding underneath that wire down there. So yeah, so that's that. This upper section is, I'm pretty sure, it's usually the power control, battery power control, because when you turn the radio off, the power still remains on the CPU until the CPU turns itself off. Effectively, it's like a latching circuit. So when you turn it on, you get power into the CPU immediately, and then the CPU effectively latches that power on. So you can if you turn the radio back off again, it doesn't turn off immediately, because the CPU effectively latches the power on through, I believe, this chip here, which I think is the same as that. Oh no, actually I'm not sure. But anyway, the CPU holds the power on until it's finished doing anything it might do to shut down. Generally, that is to save the channel information back to the memory, which in this case I think is saving to the flash. Because there's a few other things I don't quite understand about this. Oh, you notice there's an empty socket here. At the moment, I don't know what that socket's for. I presume it's some sort of external memory, so either it's another flash chip or maybe an EEPROM chip. Not too sure. Anyway, so that's the kind of difference in terms of those two. Obviously, there's some extra ICs down here on the MD-380. I must admit, I don't know what those are off the top of my head. So that's the back of the UV-380 board. One thing I've noticed, they didn't actually solder both the connectors. This is the rotary encoder switch. Oh, sorry, the other difference between the MD-380 that I might quickly touch on is that the MD-380 has only got a 16 position rotary encoder, which is an absolute rotary encoder, which means that if you move it and then turn the radio on, it can still sense the position of the rotary encoder. It's just a switch. It's just a 16 position switch effectively, whereas on the UV-380, RT3S, same radio, if you turn it off and then twiddle this, it won't know that you've changed the channel, because this isn't an absolute position thing. It just records whether you turn it to the left or clockwise or anti-clockwise. And they don't seem to have soldered one pin. I don't know if that's just laziness, probably just because these look to be hand soldered. Maybe it's slightly quicker and they just optimize that by not soldering one of the terminals on. I'll probably solder that on. I don't think it's going to do any harm, make it a little bit stronger. Anyway, so that's that side of the PCB. I've had to unsolder that connection there, which is where the antenna comes up and in, because without that you can't remove it. basically, so you have to unsolder that and obviously remove all the screws. Additionally, on these radios, unlike the GD77s, etc., they've got another 2 screws here holding this in, so it's kind of a bit more rugged than the GD77 construction. Also, there's a rubber seal around the UV-380 and the MD-380, which goes kind of all the way around. So it's, I mean, I wouldn't say the radio is in any way waterproof. It's probably just a bit more water resistant than the GD77 and, you know, the Baofeng and any of those sort of style of radios. So let's take this apart. Now you can get some interesting clues by looking at both parts to this, really. So similar to a lot of other radios, this chassis here, it's got divided off sections, so you can kind of see what each section is intended to do, because this provides RF shielding between the sections. Also, the interesting thing here is this piece of conductive foam and this piece in the casting here, which is a raised section in the casting. Now, this means that there is only, this isn't, by the way, that's just a different colour thing, it's not a piece of foam, it's just a bit of insulation by the looks of things. This means there is only one thing in here which is heat sinked out onto the case, and that is this transistor there, which is likely, well, it is going to be the PA FET. So there is only one PA FET for both bands. Even though this is a dual band radio, the design is actually a lot similar to the radio like the Baofeng RD, like this one here, the RD5R, also known as DM5R, in that there is only one PA FET. So, and what they do is, this is slightly different to the RD5R really, but it's a similar sort of thing in that what it appears to have, I'm just going to take this out of the way, what it appears to have is, I'll just spin this round, it appears to have 2 separate RF sections here after the FET, and that will provide both TX and RX, RF side, or filtering, I should imagine. Looking at these coils down this side, they're considerably larger coils, so this is going to be the VHF side of the radio, so for transmit. Now how this is switched I don't really know. I should imagine it's some sort of RF switching using like gun diodes or Schottky diode type switching, because that sort of RF path switching. So I think this is the 2 meter or VHF side, and if you look at the coils on this side, they're much smaller, so I'm pretty sure that that's what those 2 sections are going to be, which is quite a surprise to me, because the GD77 and the Baofeng DM1801 both have 2 PA FETs, so they've got a separate, and these chains are much longer for the GD77. In fact, I've got a GD. Look, actually I've got a GD77 in pieces still on the bench, so I'm just going to bring that one in. It's got a load of extra wires on it though, but you might as well compare and contrast what a GD77 looks like in terms of its RF as opposed to the UV-380. You have to remember that the GD77 is actually made by TYT, so you know they're coming out the same manufacturer. And I don't know the original dates on these things, whether actually, you know, when they were originally designed. But you can kind of see that, personally, I would have said, I'm not an RF designer, but if you look at the GD70, the design of the GD77 RF section, you can see the same sort of thing basically. There's one chain here which is going to be either VHF or UHF, maybe VHF, don't know. And here's so let's say the UHF chain. And if you look, there's separate RF FETs, so there's completely set. It's a lot more separate right the way down. And if you also notice, these RF stages, they're longer basically. So this is going to actually give you better RF performance on the GD77 and the Baofeng DM1801, which is very similar because it's basically a Baofeng clone of a GD77. So to my layman's eye, as it were, in terms of RF design, because that's not my day job, I would have said this is more likely to be a better RF. The GD77 is likely to have better RF performance, at least in terms of probably noise immunity and also spectral purity on transmit, than something like this UV-380, when you can see the RF section is relatively small here. So also the interesting thing about the design of the GD77 is, if you look, the shielding here, they've shielded off this entire area on the GD77 right back. So they're the main PA FATs. There's some driver transistors or FETs. I think they might be bipolar and not FETs, and then back through to the actual baseband chip here. Okay, so this is like a self-contained section here, which is like the RF section. So everything to do with the RF really is contained in this section, which will be shielded off by the chassis of the radio. So that's the GD77. Whereas on the UV-380, this chip here is the RF chip, which is a bit surprising. So they've got this one in its own little kind of shielded section. That's the same chip as here. It's a Alpha Tango 1846S tri-band RF chip, FM chip effectively. Whereas on here, it's in this little section here on its own, which is a bit strange. I mean, I can kind of understand that, but what I don't really understand is why they've not shielded off this, because this is the DMR chip, which in this radio is the same again as in the GD77, and it's HR-C6000 chip, and so that's the same chip in these two radios. Except this isn't an RF chip, you know, this is a digital chip, well, digital stroke baseband audio chip effectively. So it receives, it takes its audio, it generates, you know, audio, which is fed into the this chip. Well, actually, it doesn't modulate it that way, but on received, the baseband raw audio comes out of this chip and then goes into that chip there. So it kind of really doesn't make a huge amount of sense to actually have this chip not shielded from the RF, really. You know, I would have thought it'd be better at least to shield that off there if you're going to do that, or why is that chip over there in terms of design? So it's kind of a bit weird anyway, but never mind. I don't design these things, and you know, like I say, I'm not an RF design engineer by trade. You just kind of learn these things as part of amateur radio, of course. So yeah, so in terms of the radio, this radio, the RT3S or UV-380, now I think the other chips, I think this chip up here is actually the audio chip. I think it's a TDA chip, so I believe that's probably the audio. Obviously that's the RF chip. This is the DMR chip, which is the same chip as in the GD77, so a little bit more light onto it there. So really, that's it. I mean, I must admit, I'm kind of a little bit disappointed that the RF stages aren't a little bit better in the UV-380, so I'm going to contact a few people I know that have more knowledge about this. Jason, effectively VK7ZJA, and ask him, see if he can have a look at this video and tell me what he thinks, or whether he already knows much about the UV-380. But yeah, I was a little bit surprised that the design's more akin to an RD5R, which is quite a cheap radio, than this radio, which is spec'd to be a relative, well, it was relatively cheap. I mean, I think there was something like $75 US, which is cheaper than a GD77. And you know, its big selling point is, of course, it's got a big color screen and a much bigger memory. But in terms of actually the RF design, I think you maybe that's what you're paying for with the GD77, though. In you know, kind of from the outside, it looks like a, you know, a lower spec radio, but I think probably it's actually a higher spec radio, really, in terms of the RF. So that's about it, really. There's not an awful lot more to see on it, really. One thing that I haven't noticed so far is I haven't noticed an EEPROM on the GD77 and the Baofeng DM1801. Oh, actually, sorry, and the RD5R. They've all got a flash memory chip and also an EEPROM as well. Now the thing about an EEPROM is that you can write, it's got much greater number of times you can write to the memory. The number of times you can write to the flash memory is around about something like 20,000 times you can write to the same location in a flash memory, whereas an EEPROM it's something like 100,000 or beyond. Also with an EEPROM you can write to an individual address in the memory. You don't need to do anything else, you just write to it, that's fine. Whereas on a flash memory you actually have to erase what's called a page of memory, and then you have to completely refill that. So to change 1 byte in a flash memory, you have to read out a page, which is usually about 4 kilobytes, change that 1 byte, then write the 4K page back. So it's kind of not very efficient for saving small amounts of data often. So I'm not too sure with this, because I was kind of expecting to see an EEPROM and a flash chip, but it's just got a flash chip there. So I will just need to look around this board a little bit more and see what some of these other ICs are, whether that's, seems a bit small for an EEPROM, but you never know. Could be an EEPROM, or maybe, you know, I don't know what some of these other chips are. It's a bit strange to put an EEPROM up there, but you never know with the design of these things. So there we go, I think that's plenty long enough for this video, and hopefully it's given everyone a bit more of an insight into the RT3S, or also known as a TYT MD-UV-380.